Hello everyone, welcome back to my channel. So in today's lesson, we are going to talk about minimum cost spanning tree. As you see on the board, minimum cost spanning tree has two algorithms. The first one is Kruskal's algorithm and the second one is Prim's algorithm. So in today's lesson, we are going to see how we are going to solve this problem. But first, I want you to know what is the importance of this spanning tree or to find the minimum cost of this spanning tree. It's very important in terms of construction. For an example, installation of appliances, because let's say you want to give distribution of water system in your community, for an example. So first you need to do certain measurements, then you find the shortest path wherein you can pass this pipe to reduce the cost of the materials. So this algorithm is used in data structures in mathematics. We apply this algorithm in different aspects of life. So in today's lesson, you are going to see how we are going to use these two algorithms, as you can see on the board. The first one, which is Kruskal's algorithm, you can start with one node. You can start with no node, then you move to the next node. You check if this is the cheapest path, then you follow the paths. If this one is expensive, then you ignore. Okay? But for this one, you can start with no node at the initial stage. You don't know idea. You don't have any idea of what you want to do. So you can just start with, for an example here, you can see on this figure here on the board, A, if you have here A, you compare A and B, this A to B and A to H, which one is the minimum cost here is 4. So your path will be here, A to B. So you ignore this for the meantime, but make sure all the nodes are visited. So for Prim's algorithm, this one you can start with any one of the nodes. You can start with any one of these nodes. You can either start here, you start here or here. But the only issue or the similarity it has here, no node, no loop needs to be formed. Because you can't, like here, if you say D, E, F, you come back to D, then you form a loop. So no sooner you form a loop, then we ignore this one is not a minimum spanning tree. Okay, so in today's lesson, you are going to see here on the board, we have two figures. The first one is this, figure A, and the second one is figure B. So we solve figure A using this first algorithm, and the second one here, we use the Prim's algorithm. So let's see here. For this figure, we need to first form a table which has source and destination. Then we have the nodes, which is the vertices. So here we can say vertex or weight. Here we can take our weights here. Then our source and the destination. So we'll start by the least weights here. We'll start from 1, 2, no 3, we'll go to 4, no 5, we'll go to 6, 7, 7 appear twice, 8 appear twice, then we'll see here. So we'll start by 1, 2, 4, 6, 7, 7. We have two 7s here. We have 8, 8, 8, 8. Then we have 9. You have 10, 11, 11. Then we have here 14. So let's see here. So the source of this one, the source is H and the destination is G. So here we say H to G, which is 1. So 2 here, the source is G and the destination is F. So G to F. For here, the source is A, the destination is B. So A to B. 6, the source is I to G. Here we say I to G. 7, we can either take this first one here or we take this. So we can say C to D. C to D. Then the other one is H to I. H to I. 8, here we have B to C. B to C. Another 8, we have A to H. A to H. Then 9 here we have D to E. D to E. Then 10 we have E to F. E to F. 11 we have B to H. B to H. And finally 14 you have D to F. D to F. So now let's see here. From this diagram, we start from this weight 1 here. So now we are going to consider steps. First, we take this one as step 1. So step 1, the minimum cost here, H to G. Step 1. So minimum cost selected. Minimum cost selected. Selected is H to G. H to G. So we can draw, we move H to G from the diagram here. This is H to G. So we'll draw it down. H to G. We'll connect this node because the cost is just 1. We say H to G. So we'll join this H to G. That's the first step, step 1. Step 2. Step 2 here is G to F. G to F. So first, we'll connect this node from H to G, which is 1. The weight is 1. Then the next step, which is 2 here, is G to F. So we'll connect these two graphs together. But when we are connecting these graphs, we'll make sure no loop is formed or circuits. So step 2, minimum cost. Minimum cost selected because no loop is formed. So we select G to F. G to F. Draw our diagram. We say H, G, and F. So you see it connects from G to F. So here we can say this step 2. Here is 1 and here is 2. Then step 3. Minimum cost selected. First we'll check. Step 3 is 4. 4 is A to B. A to B. So we'll select minimum cost selected. A to B. So A to B will remove A to B from the diagram, which is A to B is around here, A to B. As you can see from the diagram, the position of this node in the diagram is here at the left part of the diagram. So we'll say here A to B, which is 4, Then we'll have this H. We have H, G, and F. Which is 1, 2. This is H, G, and F. We select this node because it's not connected to this and no loop is formed. Whenever we select a node that forms a loop, we ignore that node. So step 4, we'll check for minimum cost. Let's see, step 4 is I and G. I and G selected because we have G already. I and G, minimum cost selected. I to G. So now we have here A, B, and we have H, G, and F. Then we have here our I. Between H and G, we have I. So this is I. So we select A, B, and we have H, G, F, and I. So we join this, which is 4. Then this is 1. This is 2. H to G here. I to G selected, which is here. I to G is 6. I to G is 6 here. Okay. So we need to enface here. So step 5. Minimum cost. So now we'll check if it's selected. Step 5, after I and G, which is 6, C and D. Step 5, C and D, we'll check here. C and D is selected because it won't form a loop. Minimum cost selected. C to D. Now we'll start from the previous, where we have here A to B. We have this one here. Then we'll have C, B, C to D, C to D here. So after this, here we have C to D. So now we'll join. We have here A, B, H, G. This is I. This is F. This is C. And this is D. So now we join our nodes. This one join. And this join. This. C to D. So now the weights, here is 4, here is 1, here is 2, here is 6. C to D, the weight is 7. So step 6, Step 6 here, another 7, H to I, minimum cost, H to I. We'll check in the diagram here, H to I not selected because it forms a loop, because we already select H to G and I to G. So if we select this one, I to H or H to I, it will form a loop. So we ignore this one, minimum cost H to I not selected. This is not selected. Then come to step 7. Step 7, B to C. Here, B to C. Yeah, B to C selected. Minimum cost, B to C is selected. So we'll do the same diagram here. We have here A, B, we have C, have here D, then we'll have H, G, F, we have I. This is A, this is B, H, G, F, C, D, I, and we join the weight here is 4. The weight here is 1. Here is 2. Here is 6. Here is 7. The weight here is 8. Step 8. For step 8, minimum cost. So let's see if the minimum cost for step 8 is selected. We are done with B to C. B to C. Now we have A to H. So we'll check here. A to H. A to H is selected. Minimum cost A to H selected. Because this one won't form a loop. So we select this one. We have here A, B, have C, D, H, G, there is I, there is F. Let's see. This is A, this is B, H, G, F, C, D, and I. So this is 4, this is 1, this is 2, this is 6, this one here is 7, and this is 8. Then A to H selected, A to H, which is 8. Step 8. Then step 9. Step 9. D to E. So we'll come to the diagram first before we select. D to E. D to E. So this one, no loop is formed here. So D to E is selected. Minimum cost selected, which is D to E. D to E is selected. So we'll start from A. I have here A, B, C, D, E. I have here F, G, I, and H. So select. This is A, B. Here is 4. Here is 8. Here is 7. Here is 6. 1, 2. This is 8. C, D, E, F, I. So D to E is selected. D to E is selected, which is here 9. So the next step, step 10, let's see. Step 10. So first we'll check here. After these points, we have dealt with 9 steps. So step 10 here is E to F. So if we come back here, E to F, if we select E to F, then a loop will be formed. So we'll ignore E to F because this one will close the graph. Then we'll check again, B to H. B to H again will form a loop here. If we select B to H, it will form a loop. So we reject B to H. Then D to F will come again. D to F again will form a loop. So we ignore from here, from 10 here, weight 10, to this last one we reject. Okay, so now you can see here on this diagram, you can see all the nodes are visited, but no loop is formed. You can start from here, you come to this, come to node C, B, A, H, G, and I. You can also start from here, or you can start from here. You can visit all the nodes. You can start from here, you come, because this one is empty. Okay, so basically, now to calculate the minimum cost, we add all these weights here we are seeing. So minimum cost here, you can also say the shortest path, or you can say minimum cost. Minimum cost of this spanning tree is, then we'll add 4. 4 plus 8 plus 7 plus 9 plus 6 plus another 8. We have another 8. 6 plus 1 plus 2. So you add all these nodes from here, it gives us 45. So therefore, in this graph, the minimum cost, if we select this node to visit all the nodes without having a loop, is what? 45. So here the minimum cost is 45. So now we can see the other figure here, figure B, but first we need to face that part of the board, and we'll try to solve this other part of the question, which is B, using Prim's algorithm. So now for Prim's algorithm, for this one, we'll draw a table here. Let's see, where we have our vertex, key values, and parents. So this is the initial stage. Before we go to step 1, we say initial stage. This is our initial stage. So we have here vertex, key values, and parents. So let's divide this into a number of nodes. We have 1, 2, 3, 4, 5, 6, 7 nodes. So let's first divide this. This 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7 here. So here, we start from the vertex here. We can start from 0, say 1, 2, 3, 4, 5, 6. Okay, 0, 1, 2, 3, 4, 5, and 6. Therefore, for this initial stage, everything here is infinity because we don't know where we are going until we start the process. Then here we can say nil, 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 nil. Okay. So now we come to stage 1 or step 1. So step 1 here, as I said, this one, you can start with one node, then you compare the two, you choose which one is the minimum cost, then you select. You try to fill this table by steps, okay? So now we draw the same table here, vertex, key values, here parents, so here we can say minimum cost. Minimum cost here we start with 0 to 5 and 0 to 1. We compare. So 0 to 5, you have 0 to 5 and 0 to 1. 0 to 1. So which one has the minimum cost here is 0 to 5. So 0 to 5 is selected. So we'll say here 0 to 5, which is 10. This is selected, 10. So we ignore this, we select 0 to 5. So we'll first do our vertex here. Say 0, 1, 2, 3, 4, 5, and 6. So we'll first fill the table. After the table, we can draw the graph. So here, this is null, infinity here, null here. Here again, infinity, infinity, infinity. You see here, the destination here, vertex is 10, is 5. So now our minimum cost is 10. So we'll fill first this table here. Put here 10, which starts from 0 to 5. So 0 to 5 is 10. All this one is nil, nil. Can use infinity. Here is nil. Okay, so now we can select this node out of the graph. We'll say here 0 to 5, which is 10. Start from 0 to 5, 10. We'll go for the next step, step 2. Step 2 again, we'll see. So when you reach here, 0 to 5 selected, then we'll compare again 5 to 4 and 0 to 1. So say minimum cost, minimum cost 5 to 4 and 0 to 1. So 5 to 4 has 25 weights, whereas 0 to 1 has 28. So we'll select 5 to 4. This is 25. So we'll select this. Now we'll fill the table first. Vertex, key value, parents. Now we say 0, 1, 2, 3, 4, 5, and 6. So now the parents, this one, first fill this, which is 10. The parent is 0, 0 to 5, has 10. Then here, 5 to 4, 5 to 4 here, 5 to 4. The parent here is 5. So say here 5 to 4, which is 25. So all the rest here, this is infinity, nil. Now we'll do our diagram here. You just use this small space to illustrate. And here is your 4. So we'll come from here, 0 to 5, which is 10. And here is 4, 5 to 4, which is 25. Okay, step 3. Step 3 again, minimum cost. Minimum cost from 4, we have 2 region. Either will come 4 to 3 or 4 to 6. So 4 to 3, 4 to 3, and 4 to 6. 4 to 6. So which one has the minimum cost here is 22. So 4 to 3 is selected. 22 selected. I will fill the table vertex. Say key values and parents. Starts from 0, 1, 2, 3, 4, 5, and 6. So already here 0 to 5, which is 10, and 5 to 4, which is 25. And now 4 to 3, which is 22. 4 to 3, as usual here. Now we'll draw our diagram here. Start from 0 to 5. We have here 4, and we have here 3. So here is 0, here is 5, here is 4, here is 3. Here we have 10, here we have 25, here we have 22. Okay. Step 4. Step 4 here. Now we are here, 4 to 3. So step 4 again, we have two regions. We have 3 to 6 and 3 to 2. So minimum cost. So we say 3 to 6 and 3 to 2. So which one is selected here? 3 to 6 has 18 and 3 to 2 has 12. So 3 to 2 is selected because it has the minimum cost. So here, this is 12. Selected. We'll do our table again. Vertex, key values, and here parents. Zero, 1, 2, 3, 4, 5, and 6. Okay. So we have here 10, 25, 22. Then now we have 3 to 2. 3 to 2 is selected. Selected 3 to 2, which is 12 here. 3 to 2, this is 12. So this is 0, 5, 4, 3. So now we can draw here diagram again. We have 0, 5, 4, 3 here. Then we have 2. Zero, 5, 4, 3, 2. There is 10. Is 25. Is 22. 3 to 2 is 12. We will need this space here. So from step 4 here, we come to step 5. Step 5 here, we say 2 to 1 or 1 to 0. We check. Minimum cost here. We say 2 to 1 to 1 and 0 to 1, 2 to 1, and 0 to 1. So we'll compare these two. Or you can say 2 to 1 and 1 to this. But first we'll compare this one here. Then later we can compare the rest of the node. So 2 to 1 here has 16. And 0 to 1 has 28. This is 16. This is 28. So this one here is selected. Now we'll do our table here. Say vertex, key values, and parents. Zero, 1, 2, 3, 4, 5, and 6. Okay. So from that table there, we already have 0, 5, 4, 3, 0, 5, 4, 3. So now we'll select 2 to 1, 2 as parents. We'll say 2. So this one has 16. This one has 12, 22, 25, and 10. This infinity, infinity, we have null. This is nil. So we'll do our graph here. Start from 0 to 5, 5 to 4, 4 to 3, 3 to 2, 2, 2 to 1. 2 to 1 is selected. Now here we'll say 0 to 5, which is 10, 5 to 4, which is 22, 5 to 4, which is 25, 4 to 3, which is 22, 3 to 2, 3 to 2 is 12, 2 to 1, which is 16. Okay. So now step 6. Step 6 here. Here we can choose. Here we have 1 to 6 and 4 to 6. So we'll compare these two. 1 to 6 and this one. We can either compare these three. You can even say 1 to 6 and 6 to 3. Compare. So first, let's just compare this here. So we'll say minimum cost. Say 1 to 6 and 4 to 6. 1 to 6 and 4 to 6. So 1 to 6 has 14. So 1 to 6 is selected because 1 to 6 has the minimum cost, which is 14, whereas 4 to 6 has 24. So 1 to 6 has 14 is selected. Do our table here, vertex, key values, and parents. Okay, so here we have 0, 5, 4, 3, 2. This one now we have 1 to 6, so we start here 1. So 1 to 6 is 14, 10, 25, 22, 12, 16 here. And now I have this one here, and we have nil here. Okay, now let's do our graph. From 0, we have 5, we have 4, then we have 3, we have 2, we have 1, and we have 6 here. Zero, 5, 4, 3, 2, 1, and 6. Here is 10. Here is 25. Here is 22. This one is 12. 2 to 1 is 16. Then 1 to 6 is 14. So this is step 6. Step 7, we'll check. So for step 7, we can compare here. Step 7, we can either say 6 to 3. If we select 6 to 3 here, we can form a loop. So we reject 6 to 3 because you can see here, if we join this here from 6 to 3, then it forms a loop. This one is closed. So we reject. So also if we take this one, if we compare this, 4 to 6 here, 4 to 6 here, again will form a loop. So we ignore. Again, 0 to 1 here, if we select this one, it will form a loop. So we ignore these 3, this, and this. So now this is our graph. Therefore, our minimum cost here, or shortest path, is minimum cost, or the shortest path here, must be equals to, we'll add this one, the total of this. So first we start from 10 plus 25 plus 22 plus 12 plus 16 plus 14 here. So we'll add this total, 10 plus this plus 22 plus 12 plus 16 plus 14, total of 99. So therefore, our minimum cost for this one using Prim's algorithm is 99. So you can see, based on the diagrams and the way we use to solve this type of problem is very different. Okay? So basically, we dealt with 2 algorithms in data structures that we use to solve this minimum cost spanning tree, which is Kruskal's algorithm and Prim's algorithm. So you can see, give your comments on the comment section, give a like, don't forget to subscribe on the channel. Thank you for watching the video. Every week we bring new videos of the similar contents.